Part C.2, string matching. In this part, we will solve a very fundamental problem in computing. So let's look at the problem. In this problem, we want to do one thing, that is the mathematical representation. You know, to solve many problems, mathematical representation is very important. So for this one, we try to look at that part. All right. Problem number 6, string matching. All right. Let's look at the problem. Given a string of n characters, so we call this string as the text. Okay. You know, formal name. Yeah. This block of text. Yeah. Then, and another string with n characters, m less than or equal to n. Yeah. So we call it pattern. Yeah. Usually longer text and relatively shorter pattern. So we want to, you know, find a substring in the text to match this pattern. That's the problem. Okay? Find a substring of the text that matches the pattern. Here you can see this problem is very fundamental in our current web era. You need to do web search, right? You need to search information containing a particular keyword, hashtag, right? Things like that. You need to do a lot of string-based search, string search, matching. This is the fundamental problem you need to solve. All right, so here, this is our first try. So we will use the simplest method, brute force method. In our later part of the course, this one, we will look at a much more advanced algorithm to solve this problem, but it will be much more complicated. Very, very hard to understand. Yeah. Not like this one. This one, very easy to understand. But later, extremely hard to understand. Yeah. So we will try near the end of this class, where we'll have that. All right. Find its location. How do you describe there is a match, right? Find its location, the location of that substring. But how do you describe the location of a substring, right? Index I of the leftmost character. Your substring has many characters. We use its leftmost character, its index, to describe its location. Yeah. So with that definition, now let's try to solve the problem. Yeah. So you can imagine the problem is not very hard to solve, but we need to get things straight. We need to do some nice arrangement. After that, then the problem is very easy to solve. So that's why here we focus on the mathematical representation. Yeah. All right, our first solution. We use the straightforward thinking in our first solution. Yeah. So we do not use any techniques. Yeah. We do it directly. Yeah. So let's try to represent the text part, pattern part, using good notations. For the text part, the reason we emphasize mathematical representation because it can help us apply mathematical tools. That's very important. Mathematical tools. It can help us to do that. Yeah. if you do not have very good mathematical representation, even if you have some very powerful math tools, you cannot apply them. Yeah. So that's the main point. Yeah. All right, the text part. We use a sequence of n variables. Yeah. So these little t's, variables with subscripts. Right? That's the representation. Yeah. Pattern, similar representation. So we use p variables with subscripts from 0 through n minus 1. Yeah. That simple direct representation. So with this notation, now we can describe our requirement. How to describe match state. Yeah. Find location I. Okay? Suppose this I gives one matching location. So how do we describe that matching state? Like this. Ti equals P0. Yeah. Subscript I corresponds to index I. So T character array. Yeah. Here we use character array. T element in the character array with index I equals character in the P character array with index 0. The first pair of characters match. Then the next one, and so on. In the middle, the general case, T character array at the location I plus j. Yeah. So you move forward from I, next one, I plus 1, you plus j times, so I plus j. And your P index also move j step forward. So you get to pj. Okay? Yeah. Then until you reach the end. I plus n minus 1 steps, P 0 plus n minus 1 steps. Yeah. That's the precise description of a match. Yeah. The meaning is obvious. Okay. All right. Next, we try to solve the problem. Yeah. The solution is pretty simple, straightforward, but we need to solve it. Here, I give you the detail. Solve it. Yeah. All right. Strategy. Here, I want to introduce another commonly used strategy. So very useful strategy. Very simple, but usually you may not be aware of it. Usually, if you do not have the training, you may not be aware of it. So here, let me emphasize this strategy. Guess and verify. Guess and verify. I believe all of you know it, but you need to have some very strong intention to use it when you get to the right situation. Yeah. All right, so let me describe it. So 2 steps. The first step, you need to guess the result. Guess it. Yeah. Many times we need to make a guess. Yeah. But after you make a guess, how do you know it is correct? Right? It could be wrong. Nobody can make a guess with 100% precision. Nobody can do that. Yeah. So in the verify step, if you find anything wrong, you need to fix it. Then you get a right result. So that's the procedure. Yeah. thinking. Yeah. Can we exhaust all such m substrings? When we do the matching, can we exhaust all the possible m substring? So here I use this simple expression m substring because I want to my meaning that substring has m characters. Yeah. So I just use a short name for it. Yeah. All right. Every time extract an m substring from the text with consecutive characters. Yeah. We want to see how many different ways we can do that extraction. Yeah. All right. Then step 2, compare it with the pattern for a possible match. We do comparison in this one. Yeah. Okay. The first pair, second pair, and so on. Yeah. If we miss one comparison, for one comparison, no match, return false. Yeah. So we go to the next m substring. Yeah. So that's simple. Yeah. But the question is, how many such m substrings? We want to know from beginning to end how many different m substrings we need to do the comparisons. We need to do character by character comparisons. Yeah. That number, we want to have it at this point. Yeah. How to get that? Okay. Here, let us use that guess and verify approach, strategy. Okay. Let's guess it first. Can you make a guess? Just try your best to make a good guess, as close as possible. Okay? Yeah. All right, so here, let me make a guess. Yeah. Yeah. Definitely, it's not n, right? It should be shorter than n, right? Yeah, because your n string has a length n. Yeah. So I will guess very likely like this. n minus n. N minus n. That's a reasonable guess, right? Minus. You need to reduce certain number of characters. But the problem is this guess precise, very precise, so we need to verify it. Yeah. Next, let me give you a simple way to verify. How do we verify it? Let's try some simple concrete example. Let's try some special numbers to verify it. Okay? So the case I want to use to verify, m equals n. It is allowed, right? It is a special case. M equals n, special case. So your text has the same number of characters as the pattern. In that case, you have one comparison, right? Because you have one m substring, you can do the comparison. So your answer should be 1, right? But the formula you guess, n minus m, not a 1, it's 0. That means your guess is not precise. You need to make an adjustment. Okay? So what kind of adjustment to make them the same? Plus 1. N minus m plus 1. So now after that verification step helps you to make this good adjustment. After you make this adjustment, you get the correct answer. Okay? We need this many possible m substrings to solve this problem. Okay. All right, so now we can solve the problem. So after we get that critical information, next we can solve the problem. Okay. All right, so let's do the analysis. Yeah. Let's do the implementation first. The implementation, not that hard, yeah, pretty straightforward. Yeah. Suppose this diagram gives us the description of that general text. Yeah. So we have a string of we have an array of characters. Yeah, here. All right. The first M substring. Yeah, we start from the first one, then last one, right? The first one to the last one. Yeah. So what is the first one? This is the first one. The first one location, we use its leftmost index. So I equals 0. Yeah, that's the location. Okay. But the question is, what is the location of the last M substring? What is the location of the last M substring? We want to figure out. Yeah. Because when we write a program, that information is important. So we want to fix that, yeah, before we can write our program. Yeah. How to figure out this subscript? You need some way to do it. Okay? You need some way to do it. Yeah. Okay? Yeah. Here, let me introduce you another new method in this situation. And it is a very useful method. Yeah. It's called invariant idea. Invariant. This idea is extremely important in problem solving, yeah, especially solving some hard problems. You need it. Yeah. The invariant, what's the invariant? Some quantity that never changes in the different states of your problem. Because your problem states could change, right? The states could change. But even the states change, there is some intrinsic property, quantity, it never changes. So that quantity we call the invariant. So that invariant actually reflects the insight of the problem. Insight. You want to find the insight of the problem. That's not easy. That's pretty hard. If you can find it, then it is much easier to solve the problem. Okay? The insight, intrinsic property, quantity, invariant. Yeah. All right, let's take a look. Here, we can find for each n substring, the difference of two n subscripts of each substring is invariant. Is an invariant. The largest subscript minus the smallest subscript, that difference is invariant. That's our observation. Okay, so think about that. Even you move the substring, yeah, so that's why we change the state. Okay, you move the substring locations, no matter wherever you move, the difference always a fixed number, never changes. So we take that as the invariant. Here, we want to fix that question mark. Okay, so let me show you how to fix it. Yeah. First, the difference from the first n substring, you take the difference, n minus 1. Okay? N minus 1 minus 0, so you get n minus 1. How about the second one? Second one, you do not know this question mark, so let's use x to represent it. Okay, and we take the difference. So n minus 1 minus x. And these two numbers should be the same number, should be the same. So we set up an equation. Then we solve this equation for x. X equals n minus n. Okay, so we fix that question mark for t. Yeah. So the position of the last n string is n minus n. Yeah. So we fix it. Now, the last step, we can do it. Analysis. The analysis of efficiency of this problem. Quite easy. Yeah. So let's do it. Yeah. What is the best case efficiency? Best case. Yeah. When we do the first comparison, we find a match. That's the best case. Okay, so first comparison. But we still need to do m character by character comparisons. So that's why we do 1 times this n. 1 times this n. That number of comparisons. That's the best case. What is the worst case? The worst case. How many comparisons do we need to make? Right? Yeah. The worst case efficiency, this many comparisons. Remember? That's the number of comparisons. Remember in our previous slide, guess and verify. We figure out this number, right? In the previous slide, we figure out this many comparisons. Each comparison, we need to do m character by character comparisons. So that's the worst case efficiency. How about the average case efficiency? Average case efficiency, somewhere in the middle. Yeah. So, the average of these two numbers. Yeah. In this case, you can do that. Yeah. Yeah. Because you compare 1, 2, 3, 4. All the way up. Yeah. So you take the average of those numbers. Okay. You can take the average of those numbers. Yeah. So you get this number. Okay. 1. Here you have 1. Here you have this many. 1 plus this number divided by 2 times n. Yeah. You can use this way. Yeah. Okay. Because each case happens with the same probability. Yeah. The probability you do one matching operation. Yeah, let's call one matching operation. Okay, 2 matching operation, 3 matching operation, until the last number of operation, this number, that probability the same. When you have that situation, then you can do this average to get your average case. Okay. All right, so that's the part 2 string matching problem. All right, so we stop.